Hello and welcome to Lapping Analytics. My name is Jimmy Lapping. I'm a psychologist and statistician with an interest in research in a variety of areas, including the use of AI in such research. And in this video I'm going to provide a basic worked example of how to perform a chi-squared test of independence, binary logistic regression, and Brunner-Munzel's non-parametric relative effect procedure in ChatGPT. This is the free version of ChatGPT, the last free version, version 5, GPT-5. And I'm going to simply show what I've done straight away in ChatGPT. So, if you've watched some of my previous videos, or you can still do that on my channel, which are, this is part of a series on data analysis using large language models. So if you've seen a few videos before on my channel in this series, then you will have seen that I try to acquire statistics using large language models and actually using language prompts in LLM environments like ChatGPT or DeepSeek. And what I explained there is that it's important, first of all, to provide a piece of context, basic information. In this case, we have a sample of 42 independent observations for a response variable or dependent variable A and a predictor or independent variable B. So this is context that can be used by ChatGPT or whichever LLM I'm using to analyze the data correctly, to choose appropriate statistical procedures. And then we provide the data, which is in this case a vector A with zeros and ones, and also a vector B with zeros and ones. And I've said that there are 42 independent observations for a response variable A and a predictor variable B. There are 42 values in A and 42 values in B, and they will be linked in the analysis. So then I have a bunch of questions, right? Because in the previous videos that I shared on this kind of analysis, I explained that first of all there is context, then there is data, and then there are of course questions that you want to have answered, questions or an order. In this case, performing a chi-squared test of independence, because we assume independent observations. Questions 1.1 to 1.3, the first three questions are on that chi-squared test. First of all, what's the chi-squared value? Then second, at which number of degrees of freedom is this test performed? And question 1.3, what's the p-value of this chi-squared statistic? Then next, a series of questions on the use of binary logistic regression, because we use A as the response variable and B as the predictor. So we have a bunch of questions here, 2.1 to 2.11. So 2.1, what's the point estimate of the intercept? 2.2, the standard error around that. 2.3, the p-value for the intercept. 2.4, the 95% confidence interval for the intercept. 2.5, the point estimate of the regression coefficient of predictor B. 2.6, what's the value of the standard error around the estimated regression coefficient of predictor P. 2.7, what's the p-value for the regression coefficient. 2.8, the 95% confidence interval. And then I've added the likelihood ratio statistic at a number of degrees of freedom and its p-value. So those are a bunch of questions on the logistic regression procedure. And then finally, performing Brunner-Munzel's test. I want one specific statistic, which is namely the relative effect, and I just want the point estimate or simply the value of the relative effect. And let's see what ChatGPT does. I have demonstrated in a couple of videos, I think a couple of videos earlier, that sometimes ChatGPT makes mistakes in basic calculations, but I've also found that if you give very specific prompts and very specific questions, then you can reduce the likelihood of such mistakes. Now, let's just scroll down and see what ChatGPT gets out of this of this information. So, well, from your vectors we get a 2 by 2 table. A is rows, B is columns. And in this case, we see indeed these numbers, they are correct. If you were to run this analysis in R, in Python, in Jamovi, in JASP, Stata, whatever program you use, you would get these numbers in a two-way table as well. And then, well, it says the chi-squared test of independence has a value, so it yields a chi-squared value of 4.6667. Degrees of freedom of 1, because that is the number of columns minus 1 times the number of rows minus 1. So that's 1. And well, the chi-square value of almost 4.67 at 1 degree of freedom comes with this p-value here, 0.0305. So that's the chi-square test, and this is the default chi-square test of independence. It doesn't apply any kind of continuity correction that some would advocate for if the numbers were so small that the expected counts, which you don't see here but you can calculate by hand, if the expected counts were below 5 or below 10, depending on which source of literature and which program you use, some continuity correction would be applied. But in this case, the expected values are 10.5 for each cell. It's basically row total times column total. So row total times column total divided by the overall total. So that would yield 10.5 as expected value for each cell. That's above 10. So that's why that's most probably the reason why ChatGPT doesn't provide a continuity correction here. It just calculates the default chi-squared test. Okay, then we had a bunch of questions on the binary logistic regression. In this case, question 2.1. It is, in this case, minus 0.693. And what it says log here, that's actually the natural logarithm that is calculated. And well, when we see the standard error, that is 0.463, the p-value is 0.134, a 95% confidence interval for the intercept is this. And well, I have cross-checked all these numbers that I'm showing you with R and with other programs that we can use for this kind of analysis, and they are correct. There are no mistakes in the outcomes that are provided by ChatGPT. Beta 1, or the regression coefficient, in this case 1.386, standard error is provided, p-value, so that is statistically significant at the 5% level, tested two-sided, 95% confidence interval, and then the likelihood ratio statistic, which is basically which is the statistic that compares the full model, which in this case has predictor B, to a null model which only has an intercept. That yields a likelihood ratio statistic of 4.75, which is also treated as a chi-square test, and well, with 1 degree of freedom. Why 1 degree of freedom? Because the difference between the two models is the predictor B, which has 1 degree of freedom because there are two categories and only a dummy variable in fact, and that comes with 1 degree of freedom. Number of categories minus 1. And the p-value of that likelihood ratio test is also below the conventional 5% significance level. So this would also be statistically significant, at least at the 5% level. And then Brunner-Munzel's test, which I'm not going to explain in much detail. You see a little bit of a description here. If you want, I have several videos on my channel on the Brunner-Munzel test as well, where I explain in more detail what exactly happens there and what this kind of statistic means. But in this case, it provides a relative effect statistic, which also can be roughly it's convertible to correlations. And in fact, in this kind of special case, where we have as many zeros in a equals 0 as we have ones in a equals 1, and we have as many ones b equal 1s for a 0 as we have b equals 0 for a is 1, so this is symmetric. In that specific case, this number here can be multiplied by 2 and then minus 1, and you get a correlation coefficient, which would be about 0.333. You can run those numbers in any statistical software program and you would get a correlation, regardless of whether you calculate Pearson, Spearman, Kendall, you would get 0.333, because in a two-way table all those coefficients yield the same outcome, and they yield the same outcome as Cramer's V. So in this case, so this times 2 would be 1.6667, no, sorry, 1.3333 approximately, minus 1 point, so that would be 0.333. Okay. So this is the relative effect as per Brunner-Munzel's test. And well, then here ChatGPT suggests that it can also provide some other outcomes, such as odds ratios and risk differences, which are easier for the interpretation. The odds ratio here would be 4 for the regression for this model, because there are so basically the proportion of ones in the a equals 1 group is 2 times the proportion in the other group. So, and then it would be so if you do that calculation, you would get an odds ratio of 4. So yeah, this is still what ChatGPT could provide, but in any case, all these outcomes here are correct. So again, this is as in some of the other videos that I've done in this series. It's a way to show that the only numbers that I provide here is data. The rest is just really like language. Okay, and the sample size 42, but the rest is just questions. And well, in one video I've even shown that instead of zeros and ones, which is just codes we use, even if you use text instead, that you can still do statistical analysis using a program like ChatGPT or DeepSeek. Okay, so I hope this was useful. In next video I will also show how to do this in DeepSeek, and in another video also how to do this in Claude, which is another AI environment. Okay, bye bye.